Hello, this is Mesos Orum, and welcome to the SFML tutorials. Today, we will be working on our physics and entity class. First, we need to add a lot of variables. First one will be our gravity, which will be SF, vector 2F, gravity. We will need to know our mass, which will be float mass. We will need to know our radii, which will just be the length and width of our entity, which will be SF vector 2F, and radii. We will need our position, velocity, acceleration, and force, SF vector 2F, position, SF vector 2F, velocity, SF vector 2F, acceleration, and SF vector 2F, force. We might want rotational physics, so we will say float, rotation, float, angular velocity, which will just be ang velocity, float, ang acceleration, float, torque, and our moment of inertia, which will just be float, moment, inertia. We may want friction, so we will say float friction and float angular friction. For ease of use, we may want to check if we want gravity, so we will say spool has gravity. And also we may want to loop from the sides of the screen, so we will say spool looping. We need to initialize our variables, so we will say void init variables. We will do our various getters and setters down here. Void set mass, which will take in float mass. We may want to get our position, so we will say SF vector 2F, get position, make that a const. We'll also want to set our position, so we will say void set position, and make sure that it's an SF vector 2F with position inside. We'll want to set our velocity, so we will say void set velocity, SF vector 2F, velocity. Ultimately, we'll want to use our Newtonian force, so we will say void add force, and take in SF vector 2F, force. We'll want to get, set, and add to our rotation, so we will say float get rotation, make that a const, void set rotation, and set that as a float theta, as well as void add rotation, which is float theta. We'll scroll down a bit. Our next function, we will float get angular velocity and make that a const, as well as void set angular velocity, and that will be a float angular and velocity. Just like add force, we will add torque, so we will say void add torque, which will be float torque. We need to set our moment of inertia, so we will say void set moment of inertia, which will take in a SF vector 2F size, which is basically our radii. We'll need to get and set our radii, SF vector 2F, get radii, which will be a constant. Scroll down a bit. Here we will say void set radii, which will be SF vector 2F, radii. We'll need to set both of our frictions, so we'll say void set friction, which will take in a float friction. We'll also take in our angular friction. We will say void set ang friction, which will take in a float angular underscore friction. We'll need to set whether we have looping or gravity, so we will say void set has looping, which will take in a bool of looping, as well as void set has gravity, which will take in a bool of has gravity. For our main two functions, we will say void loop, which will take in an SF_Vector2F of window size. And we will need an update, so we will say void update, which will take in a float of delta time, as well as the same window size. And scrolling up, we will quickly define all these variables. And we will make this a little bit better looking. For our initialized variables, first we will say gravity equals 0.0f and 9.80665f. That is the same as standard Earth gravity, meters per second squared. Our mass by default will say mass will equal 1.0f. Our position will be at the origin, so we'll say position equals 0.0f by 0.0f. Our velocity will be the same, so we will say velocity equals that. And our force will be the same, so we will say force equals that. Our angular velocity, angular acceleration, and torque will all be 0, so we will say angular velocity equals 0.0f, angular acceleration equals 0.0f, and our torque will be 0.0f. Both of our frictions will be 1.0f, so friction will be 1.0f, and angular friction will be 1.0f. We will say our radii will be 1 by 1, so we'll say radii equals 1.0f by 1.0f, and this would make our moment of inertia 2/12, which would equal 0.16667f. By default, we'll say that they don't have gravity or looping, so we will say has gravity equals false, and looping equals false. In our constructor, all we need to do is say init variables. We'll scroll down a bit, give us some room. Go in here. Here we will say this mass equals mass. In here, get position. We will say to return position. In here, we'll copy this, say this, position equals position. In set velocity, we'll just copy this, say this velocity equals velocity. In add force, we will say this force plus equals force. In get rotation, we'll just return rotation. In set rotation, we'll say rotation equals theta. And in add rotation, we'll just say rotation plus equals theta. Scrolling down, go in here, say angular velocity. We will copy that, and then say angular velocity equals our angular velocity up here. For torque, we will say this torque equals torque. For setting our moment of inertia, we'll say moment of inertia equals mass multiplied by our size dot x. We will square that, so we'll say times itself plus our size dot y. We'll also square that, multiply by itself, and then divide that by 12.0f. To get our radii, just copy that for now, and we will just return our radii. For setting our radii, we'll just say this radii equals radii. And friction, we'll say this friction equals friction. For setting our angular friction, we will say angular friction equals angular friction. Setting whether we have gravity, has gravity equals has gravity. This looping equals looping. In our loop function, we will say SF_Vector2F diameter equals radii multiplied by 2.0f. For ease of writing, we will say SF vector 2F next position, which will equal this get position. For our offsets, we will need float cx equals window size dot x plus diameter dot x, as well as float cy equals window size dot y plus diameter dot y. If our entity's x position is too low, we'll say float next position dot x is less than our negative diameter dot x. Then our next position dot x will equal cx. Now if our x position is too high, we'll say if next position dot x is greater than cx, then our next position dot x will equal negative diameter dot x. And we'll scroll down just to give us a little room. If our y position is too low, we will say if next position dot y is less than our negative diameter dot y, then our next position dot y will equal cy. And if our y position is too high, we will say if our next position dot y is greater than cy, then our next position dot y will equal negative diameter dot y. Finally, we will set our position. Set position as next position. And I just realized that that is spelled incorrectly. We'll say next position and apply that. Down in our update function, we'll scroll down, give us a lot of room. We will need a very small number, so we will say float small num equals 1.0 e to the negative 12. First, we're going to check if we're looping, so we will say if looping, then we're going to loop. And it'll be window size we put in there. For a force, we will say if absolute, I'm going to copy this, the absolute of force dot x is greater than that small number, or the absolute of force dot y is greater than that small number. Then our force will multiply and equal our friction. If we have gravity turned on, if has gravity, then our force will plus equals our mass multiplied by our gravity. Then we will set our acceleration to equal force divided by our mass. For acceleration, we will say if the absolute of our acceleration dot x is greater than that small number, or the absolute of our acceleration dot y is greater than that small number, then our acceleration will multiply and equal our friction. And our velocity will plus and equals our acceleration multiplied by delta time. For our velocity, it's about the same. If our absolute of velocity dot x is greater than that small number, or the absolute of our velocity dot y is greater than that small number. Our velocity will multiply and equal our friction. Then our set position will get position, and plus our velocity multiplied by delta time. We'll scroll down, give us a lot of room. If our absolute function, our torque, is greater than that small number, our torque will multiply and equal our angular friction. Our angular acceleration will equal our torque divided by our moment of inertia. Now if our absolute of our angular acceleration is greater than that small number, then our angular acceleration multiply and equals our angular friction, and our angular velocity will plus equals our angular acceleration multiplied by delta time. And finally, if our absolute function of our angular velocity is greater than that small number, then our angular velocity will multiply and equal our angular friction. Then we will set our rotation to equal get rotation plus our angular velocity multiplied by delta time. Now back in our entities.c++ file, here we'll take this out because we no longer need it. We will say get position.x, copy that, and just change that to a y. We can also copy this, paste that there, then delete this. For our theta, we can get rotation and delete this. Scrolling down, here we will say our radii will equal SF vector 2f of size, and we will copy this, go here, and then set our moment of inertia as the same thing. Scrolling down, here we will just say update, and inside we will say delta time and window size, then delete this. Now I fixed a few things. Up in the animate class, this is less than and equal to 0.0f and not just less than. The same thing I also changed in the sprites class. In the textures.c++ file, scrolling down, here I made an error. Instead of set frame timer, it was set frame timer max, so that needs to be changed. And I think that was everything. Thank you for joining me today. If you did, then please like, comment, and subscribe, and have a great day.